Well, it's been a while, YouTube. I figured I would come back and revisit a project I worked on in the past, since I've gotten a lot better at coding and have some more insights to share. So the question we're going to answer is, are league roles evenly balanced? As part of this, I'm going to do a bonus on revisiting AI for coding, specific to this project. You can find out more on that in the course in the description. So this is the course I have that takes you from knowing absolutely nothing all the way up to building your own Riot Games app. It's called the Riot API Bootcamp, and you can look at all the details in the description below. Like I said, the question we want to answer are the roles equally balanced? This is referring to League of Legends at least. Each role has different styles and power levels which are variable over the game. For example, your AD carry is very weak early, but very strong later. Something like your mid laner may be strong, or an even-ish strong level power level throughout the game. We need a way to say whether this is good or bad. So what are we going to look at? It's either good or bad in terms of whether you win the game or not. So let's look at the win rate. Where will we get the data? We need some ideal version of the game state. So let's just assume challenger players are the best players. Well, they are the best in terms of ranked. Whether it represents an ideal game is a different matter, but it's the closest we got. So by answering that question of are the roles balanced, we'll look at the distribution of roles in challenger. How will we do that? By looking at their match history. So converting this to a task list, we're going to get the list of challenger players, go through each player's match history, identify the role in each match, identify their most common role, and then tally up the role counts. Ideally, this will show us what the common roles are in Challenger, so whether there's a lot of supports, a lot of AD carries, a lot of junglers, and the like. Let's jump into the code. I've got up my coding environment here, and first up, as always, let's import some of the libraries. So I've imported Riot Watcher, which is the library we're using for this, .env, which will allow us to load our API key, and Pandas, which is a data analysis package. Next, we want to load in our API key so we can make calls to the API. I've done this by just creating a simple function. If you've taken the course, you know exactly what I'm talking about. But essentially, we load in our little string that says we're authorized from a text file here, a .env file, and then apply it to LoWatcher and Riot Watcher. To get started, we need to set a region and a queue. I'm simply using North America because that's the server I play on, and we're looking at rank solo 5v5. We can start pulling the data now. First, we'll need the challenger ladder. So the way you can do this is by going to your LoWatcher league, challenger by league. You put in our region, so that's NA, and our queue type, we're looking at rank solo 5v5. I've converted it to a data frame, so it's easier to work with. So that's this pd.dataframe. Now let's take a look at what we've got here. So this is what the data that we get out looks like. So there's one row for each person. It shows us what league this is. So it's challenger here, checks out. Queue is what we wanted. Entry field, we have our summoner ID and maybe some other values. But ultimately, this is what we want to work with. That is the player in the leaderboard. Like I said, we only really care about this entries field. So let's pull it out and see what we got. Within the entries field, there's a summoner ID, PUU ID, LP, rank, wins, losses, and the like. This PUU ID is the unique value that we're going to use to reference our players going forward. It's how the Riot API actually operates in the backend. So if you give it a PUU ID, you can basically get anything. Now, before scaling this up, let's do a walkthrough with a single player before we convert it up to a function and then iterate over all of them. So firstly, we want to get the match list, so their match history for each player. I've gone ahead and taken the first player, so that's this challenger player's ILOC0 PUID, got their PUID, and we feed it into their match list. Right now, I'm only asking for their first match, which is their most recent game, and it'll give us the match ID, which is an identifier of each match that's played in League of Legends. Now that we have that match ID, we can get some match details. So you get the match details by feeding in the match ID to this function here, match by ID, from LoWatcher. Within it, there's a JSON file that gets returned. You can read on the Riot API website for what it contains, but ultimately we want the information of the match, so what are our stats are contained, and stats are associated by participants. So we go to participants and we pull that out here. We want to find the specific player we're looking at. We get our PUID, and we try and see if the participant in our participant structure actually matches the PUID we're looking at. From that, we pull out the lane and the role. So it looks like the number one ranked player right now, their most recent game was top solo. They played top lane, and the role identified by the Riot API is a solo player. This is important because in bot lane there are two people. I've popped open my variables here so we could actually look at the participants' data if we were interested. So let's pull it open here. It shows everything that we can actually access. So there's player score. There's actually pings in here. So if you wanted to check who's pinging you after the match, you could do that as well. But essentially, this is like all of our details that we're looking at. In case you're curious, this is actually what gets returned by the API. So our library actually handles it in the backend. That makes things easier for us. But if you're interested, there's actually an example in the GitHub for this. Now let's scale up to see what is the lane and role played in the last 10 games. We've got our PUID, we're pulling that match list, we're looking at 10 games here, and we want to store the lane and role combinations so we can reference them later. For each match, we pull out that lane and role as seen here, and we print it out as seen here. And then at the end, I do a quick check to see what is the most common combination there, i.e. what role do they main the most often. So running it for that number 1 ranked solo queue player, see that they played top, then they played bottom, so AD carry, then they played top, and they played support. Right, but their most common combination is a top laner. So this person looks like they're probably a top laner main. So we know how to do it for one player. Let's scale it up to all the players on the leaderboard. I've converted what we had into a function, so we're getting the last n games, and then in each match, we're looking at their lane and role. There's a clarification here for bot laners because we need to distinguish between AD carry and support, but other than that, it's the same as we had before. I also went ahead and mapped the PUID to an actual game name so we can look at the player that we're looking at as opposed to just a string of numbers and letters. Now, I'm looking at the 10 players on the leaderboard just to save time. And we run that function over those top 10 players, and then we print out our results. The results are actually stored as a data frame just to make things easier, but let's run this and see what we get. The number 1 player, not scared to lose, is a top laner, as we expected. And in their past couple of games, out of the, let's see here, 3 games we looked at, 67% of them were top lane. So obviously, if we wanted to get better quality data, we would increase the number of games here, but I'm just doing this as an example. Number 2 looks like an AD carry. There's a bunch of supports here, so maybe supports are overrepresented in the data. We'll see. But this is already giving us some insights there. In fact, speaking of analysis, here's some questions we should think about. What is the base rate? Well, for us, it should be, There's 5 lanes. The relative prevalence should be 0.2. It says 1 in 5. How should we visualize this? Does this trend hold across regions? Just things to keep in the back of your mind as we go through and now analyze the data that we have. Keeping those analysis questions in mind, I've put together this code below. So we extract out the most common lane from above. We normalize it so it's a relative prevalence instead of just a count of each one, and then we plot it out on a bar chart. I've set a threshold here at 0.2, so this is going to be a horizontal line that shows us that 0.2 threshold if everyone was even. So let's go ahead and run this code and see what comes out. And here's our chart. So this is looking like from our very small data size, jungle and support are a little overrepresented. If you want this as a pie chart, it's the same information. I personally prefer a bar chart because it's easier to understand, but that's available here as well. Alright, I took all of what we've learned so far and put it into one code block. So this is the same information we had before. You can see our different functions here. I put it in one place. We're going to look at the number of 5 matches, so the 5 most recent matches, amongst the 75 top challenger players. We're going to plot it as we see before. So 6 minutes of runtime later, and you can see that support and ADC are overrepresented in the data. Now this could mean that they are duo queuing. I don't think you can actually duo queue in Challenger. Someone would have to correct me on that. But looking at the data, it just seems like support is the most massively represented. So this could mean either support players are really good and they're disproportionately becoming Challenger, or maybe the support role is over-tuned compared to anything else. Bottom is in here for mages, by the way, so that's just an artifact of the data. Now, we can extend this further. How does that change across patches? Does this mean if we buff some ADCs, maybe they get more overrepresented in our mains? Secondly, is win rate even the right metric? Are we looking at the right thing? I would argue yes, but this requires further analysis. Maybe think about it a little more. As I mentioned before, is role even the right thing to look at in terms of balance? We saw there's a little bit of bottom in the data, and it showed that mage ADCs, so APCs, they're not as represented in Challenger, but maybe their win rate is higher and there's just less people in Challenger playing. So is role even the right thing to look at here? You could have better being subjective. The last part of this I'm going to leave for the course, so if you're interested in that, just check it out below. But we're going to look at how does AI help us in terms of creating this code and creating our analysis. If you're interested in that, like I said, check out the course in the description. Other than that, I'm going to end the YouTube video here. So thanks for watching, guys.